The driver of a 1,000 kilogram car traveling at a speed of 16.7 meters per second applies the car's brakes when he sees a red light. The car's brakes provide a frictional force of 8,000 newtons, and we're being asked to determine the stopping distance of the car. So I'm already provided with three things that can help me solve this equation, and that's the mass of the car, which was stated as 1,000 kilograms, speed of the car, which is 16.7 meters per second, and the frictional force of the brakes, which is 8,000 newtons. So to solve this problem, I just simply applied the work energy theorem, and I already know that the car's kinetic energy is lost due to the friction. So the change in the car's kinetic energy can be equal to the work done by the frictional force of the car's brakes due to what's stated in the work energy theorem. First that means I have to determine the kinetic energy, which is this formula right here, which is halving the mass times the velocity squared to get the kinetic energy. So I plugged in the mass and the velocity, which is 16.7, and the mass, which is 1,000, and I halved it, squared it to get 139,445 joules. Joules is the unit to use to measure energy. And since the energy is equal to the work done by the brakes, and I already have the force applied by the brakes, I use this equation to find the work that's done by the brakes. And I assume that this is my stopping distance, and I know that the direction of the applied force and the displacement are in opposite directions of the angle 180. So I times this side by -1. So that would leave the force being 8,000, -8,000, and this still being our assumed stopping distance. Now, I know that the kinetic energy, which is stated right here, is equal to the work done or the net work. So I take everything I've known so far and I plug it into this principle. So I got the kinetic energy final, the kinetic energy initial, -8,000 newtons, and I assume stopping distance. So for the final kinetic energy, it's 0 minus 139,445 equals -8,000, and times our stopping distance. So the 0 disappears and stays, and this 139,000 stays behind, and I divide both sides by -8,000 to get this new equation. So I divided 8,000 into 139,445 to get that the assumed stopping distance is equal to 17.4 meters. So that means it took the car 17.4 meters to come to a complete braking stop.